To today's tutorial. So in this tutorial we're going to be looking at we're going to be discussing increasing and decreasing functions using calculus. How can you know that this function is increasing at this point or it's decreasing at this point? So we're going to look at this question. So if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button and also click the notification button there so that you get notified of every video that I'm going to be posting. Alright, so in calculus, or if you hear that the function is increasing at a particular point, it simply means that it simply means that at that point, if let's say for instance the function is increasing at a certain point, it means that at that point, if for instance the function is given as y is equal to something this side, which is the let me say if y is equal to maybe ax, it means that dy dx at a given point is greater than 0. So if dy dx is greater than 0, it means that the function is increasing. So what do we mean if we say dy dx is greater than 0? Remember, dy dx is also known as the gradient function. So dy dx is equal to the gradient function. So dy dx is equal to the gradient. So if we say the gradient is greater than 0, it means that the gradient is positive, and all the positive gradients are considered to be in this format. It means that the function is increasing at that particular point. And then if we say dy dx is less than 0, it means that the function is decreasing. And when the function is decreasing, it means that at that particular point the gradient is in this format. It's like this, meaning it's decreasing. And we know to say dy dx is a gradient function, and when we say the gradient is less than 0, it simply means that the gradient is negative. Hence you can have at that point you have to know to say the function is like this. So for instance, if you have a parabola, you have a parabola like this. When you look at this part, this side we can say it's increasing because the gradient is positive, and it's decreasing this side because the gradient is negative. So at this point, we expect every point that is this side, if we replace it in a function of this parabola, you discover that, in the derivative of this parabola, you discover that dy dx at every point this side is going to be greater than 0. And then this other side, dy dx at every point this side is going to be less than 0. Now the question comes in, what of this point here, where the gradient is neither increasing nor decreasing? At this point, we consider this to be a stationary point because at this point dy dx is just going to be equal to 0. It's going to be a stationary point. So this one can either be a maximum or a minimum. So in this case it's a maximum, and then it can also be a minimum when you have a function which is like this. So it's going to be a minimum when the function is like this. So at this point the gradient is equal to 0 because it's neither increasing nor decreasing. So for such a function as this one, this side you can say the gradient is decreasing, meaning dy dx, this side will be less than 0. And then for this other side, since the gradient is increasing, dy dx is going to be greater than 0. So these are the concepts that we're going to use to solve question 28 and 29. Alright, so let's quickly begin to solve the questions. Okay, so let me just erase everything. Okay, so this is what we have. Let's now take a look at the questions. So the question is asking us to find the intervals of increasing and decreasing of the functions that have been given. Alright, so how do we do this now? This one is straightforward. So let's get the first function. I'm going to say let y be equal to the first function there, which is x cubed minus 12x plus 1. So if I let my y to be equal to that, the first thing that I need to find is the gradient function. So the gradient function is simply just dy dx. So dy dx is now going to be equal to, we find the derivative of this function. So the derivative of the first term here is going to be 3x squared. Then the derivative of the second term here will just be negative 12. Then the derivative of 1, since 1 is a constant, it has no variable, hence the derivative of every constant is equal to 0. So this one is just 0, so we can't write it if we want. Okay, so from there we can now find the interval. So how do we find the interval of the function which is increasing? So we know to say that when the function is increasing, for increasing functions, so for increasing functions, for the function which is increasing at a given point or on a given interval, dy dx in that interval is always greater than 0. So in other words, we're trying to say this function is going to be greater than 0 if the function is increasing. So we're going to say 3x squared minus 12 is greater than 0. Hence, we can find the value of x. So first of all, before we do that, we can first find the critical points of this given equation. How do we do that? So we let this equation 3x squared minus 12 be equal to 0, so that we have 3x squared is equal to 12. Then when we divide everything by 3, we're going to discover that the answer that we're going to get is x squared is equal to 4. So now let us find the square root of x and the square root of x squared and the square root of 4. So x is equal to plus or minus the root of 4. And then when we find that, the value of x will now be equal to plus or minus 2. So the values of x that we have are simply just x is equal to 2 and x is equal to negative 2. So these are called critical points. These are not final answers, but critical points. So we're going to test these critical points to see the interval in which this function is going to be increasing. So how do we test such intervals? So how do we test that? I'm going to draw a number line here. So in this number line, I'm going to put my critical points. I have negative 2 and I also have 2. So the interval this side is from negative infinity up to negative 2. Then we also have the interval in between negative 2 and 2. Then we also have this interval from 2 to positive infinity. So we are going to get any number that is less than negative 2, and I believe we can get negative 3. And we're going to test it in this equation. We see if the answer that we're going to get is going to be greater than 0. Okay, so if we get negative 3, because we know that negative 3 is less than negative 2, so we put negative 3 there where there's x. What are we going to have? So we're going to have something like 3, then we put negative 3 there, which will be squared minus 12. Let's see the answer that we're going to get. So this will simply just be equal to, so we have, this is 27. So this is 27, and then we say 27 times 3, that will give us something like, is it 81? Yeah, so this part gives us 81, then minus 12. So 81 minus 12, you're getting 69. So 69 here is a positive answer. So is 69 greater than 0? So we have 69 after putting negative 3 this side. We're getting 69, and which is a positive answer. So is positive 69 greater than 0? If the answer is yes, it means that this is one of the accepted interval. This is one of the interval that we are looking for. Let us try to get any number in this interval from negative 2 to 2. And I believe in this interval we can even get something like 0, because we know that 0 is between negative 2 and 2. Let's try to put 0 where there's x there. We put 0 where there's x. So if I put 0 there, I'm going to have 3 0 squared minus 12. So in this interval, in this expression, 3 times 0 will give me 0 minus 12. Then 0 minus 12 will simply just give me negative 12. So negative 12 is the answer. Is negative 12 greater than 0? The answer is no. So here we found a negative answer. This side we found a positive answer. So in this case we found a negative answer. Is negative 12 greater than 0? The answer is no, meaning this interval is not going to accept. So this at this interval the function is not increasing, because in this interval from negative 2 to 2, the function is, the dy dx is giving us something that is less than 0. And we know to say when dy dx is less than 0, then the function is decreasing. So this side the function is increasing, so this side we can say the function is increasing. Then here the function is decreasing. Let us check if this other side the function is increasing or decreasing as well. So we get any number that is greater than 2. That is greater than 2, because this interval says we have numbers from 2 to positive infinity. So we get any number that is greater than 2. We can get 3, 4, any number as long as it's greater than 2. So we replace it where there is x there. So we're going to say 3, and then we put 3 there. Since 3 is greater than 2, then we say minus 12. So we have, this is 81 minus 12 again, which gives us 69. So 69, this one is a positive answer. So is a positive number, or is 69, positive 69, is it greater than 0? The answer is yes. So meaning in this interval the function is also increasing, because dy dx in this interval is greater than 0. So the interval at which the first function is increasing, this function here, the interval at which this function is increasing is simply just so it's increasing in the intervals negative infinity, negative 2. You can combine them by using union, and then 2, infinity, and then it's decreasing in the interval so it's decreasing in the interval negative 2, 2. So this is how you find the solution to such expressions. So the solutions are quite long. The only important thing that you need to know is that when the function is increasing, dy dx is greater than 0, and when the function is decreasing, dy dx is less than 0, and at stationary point dy dx is equal to 0. Okay, so I think let me also solve another one. Let me also solve another question. So I'll solve which one can I solve? Trying to look at least something that is a bit complicated, a bit complex. Something at least which one? Okay, so we've solved this one, is algebra. Which other function can we get? So it's just a matter of differentiating all these functions. You differentiate it, and then you, if you want, you can start first by finding for the decreasing. For me, I started with increasing, so I used greater than 0. So if you want, you can start with less than 0, which is decreasing. Yeah, and then you find the intervals at which the function is decreasing, then the remaining interval will be for the increasing function. So let us try to get another function. Okay, should we solve this one? But I think the concept is straightforward. Okay, let me just get a trig function, then we move on to the next question, because all these questions here, this is algebra, and I believe the same things that I was doing here are the same things that you are also supposed to do. Okay, before I solve that, let me get this one here, because some of you think maybe critical points will always be 2. This one has 1 critical point, so let us try to solve this one, and then from there I'll solve the trig one, and then we'll move to the next question. Okay, so we get another question. We have this one. So also say let y be equal to x squared plus 2x plus 2. So for this function, we also first have to find dy dx. So dy dx for this function will just be 2x plus 2. Okay, so after finding dy dx, the next thing that you are going to find or that we are going to determine is the interval. And how do you determine that? You first have to find the critical points, and then you use that to find the interval. But you can't just find the interval without knowing what you're finding. Is it for the increasing or decreasing part? So if you choose to start with the increasing part, okay, let me choose the decreasing part, since in the previous question I chose the increasing part. So I'm choosing the decreasing part. So I'll say if when the function is decreasing, so when the function is decreasing, we expect dy dx to be less than 0. So meaning this function should be less than 0 when the function is decreasing. So 2x plus 2 should be less than 0. So to find the critical point, we're going to equate this to 0. We say let 2x plus 2 be equal to 0, and the value of x, when you simplify this, you find it to be -1. You take this 2 to the other side of the equal sign, then you divide by 2 on both sides. Alright, so let's quickly do that. So this is a critical point that we have found. So it's this point that we're going to use to determine the increasing and the decreasing part. Okay, so I'm going to put my -1 there. So I expect this interval from this side to run from -infinity to -1. At -1, this is a stationary point. That's where this curve turns. Yeah. So we can't get -1. That's why I'm using an open bracket here. Well, we can't get -1. -1 shouldn't be part of the interval where the function is either increasing or decreasing. So this other side, we get from -1 to positive infinity. So we can test these points from -infinity to -1. So we get any number that is less than -1. We can even get -2. So if we replace -2 in this expression here, we're going to have 2 times -2 and then plus 2. This will give us -4 plus 2. And when you check this expression, when you check this function, when you add these, you're getting -2. So is -2 less than 0? If the answer is yes, it means that so what we found here, by the way, is a negative answer. So is a negative number less than 0? If the answer is yes, then this part qualifies to be a part or an interval where the function is decreasing. So on this part, we consider the function to be decreasing. So we consider the function to be decreasing on this part, and then on this other part, we can't just conclude that the function is increasing on this other part. Yes, we know that it's going to increase, but we have to show that. How? Let us try to find any number that is greater than -1. We can even get a 0. Replace it where there is x there. We'll see if we're going to get the answer that is going to be greater than 0. Okay, because we know to say for every when the function is increasing, the gradient function is always supposed to be greater than 0. So let us try to do that. We replace 0 there. We've chosen to get this to get 0. Hence, when we replace 0 there, we're going to have 2 times 0, 2 times 0 plus 2, and then this will give us 0 plus 2, which will just be 2. So 2, this is a positive answer. So positive 2 is positive, yes, meaning this side the function is going to be increasing. So this side we found a positive answer, so we write our positive there. So is a positive number less than 0? No. So if it's not less than 0, meaning the function here is not decreasing, and hence it's what? It's increasing. So it's increasing this side. So the interval at which the function is decreasing, the interval in which the function is decreasing is simply just from negative infinity to negative 1. Then for increasing, the interval in which the function is increasing is simply just equal to negative 1 to positive infinity. Okay. So the same thing that I've done here is exactly what you do even for other functions here. So let us try to solve one trig function. Okay, so we get one trig function there. So we can get f of x. So we say let y be equal to x minus 2 sine x. So we first have to find dy dx as usual. So dy dx, when you differentiate this part, you get 1. Differentiating sine x will give you 2 is a constant, so we can just write it there. Then when you differentiate sine x, you always get cos x. So I think we can now so from here I think we can now find the critical points, and so that we determine the interval. Then how do we do that? First of all, let's consider this function to be decreasing. So if it's decreasing, then if the function is decreasing, then if the function is decreasing, then this whole function 1 minus 2 cos x should be less than 0. Okay, so let's take this to the other side of the let's find the critical point. So how do we find the critical point? We say let 1 minus 2 cos x be equal to 0. So we take this one to the other side of the equal sign. We have negative 2 cos x is equal to negative 1. Then we divide everything by negative 2, divide everything by negative 2. Then we find cos x to be equal to 1 over 2. Then to find the value of x, we say x is equal to cos inverse of half. Yes, so we have x is equal to cos inverse of half, meaning the value of x will be equal to so we know that cos inverse of half is simply just 60. So cos inverse of half is simply just 60 degrees. So if you want, you can take 60 degrees, or you can take it in radians, which is just pi over 3 radians. You can either use degrees or radians. Okay, so I'm going to go for degrees. Okay, so let us now check. Oh, this one, by the way, this one is not the answer. This one is not the answer. It's just a reference angle. So this one is called the reference angle. So this one is the reference angle. Then let us determine where this angle lies. Is it in the first, second, or third or fourth quadrant? So in the first quadrant, all trig ratios are positive. Second quadrant, only sine. Third, only tan. Fourth, only cos. So we know that the angle is positive. So since it's positive, it means that it's in the first and fourth quadrant. So we know that in the fourth quadrant, or we start with the first quadrant. So in the first quadrant, we're going to get the same reference angle to be our solution, which is 60 degrees. And then in the second quadrant, in the fourth quadrant, we find the value of x to be, so find the value of x to be equal to, we're going to say 360 degrees minus the reference angle, which is 60 degrees. So the value of x becomes 300 degrees. So now, after finding these two solutions, we can now put them on the real line. So we're going to have 60 degrees there. We'll also have 300 degrees there. Let us find the interval in which this function is increasing and decreasing. So how do we find that? This one is straightforward. We know that all the angles this side are running from negative infinity to 60 degrees. Then in between here, they are running from 60 degrees to 300 degrees. And then this side we have 300 degrees to positive infinity. So we can test these intervals. So if we get any value of x that is less than 60 degrees, let's say we get 30 degrees. So I'm using special angles because I know special angles are easy to deal with. So I've gotten 30 degrees, which is also a special angle. So if I put 30 degrees in this expression, while there's x there, am I going to get something that is less than 0? Let me try. So if I put 30 degrees there, what is cos 30? Or maybe let me not even use 30 degrees, let me use 0. 0 is the simplest value. So if we say cos 0, the answer is 1. So this is just going to be 1 minus 2. Cos 0, I've said the answer is 1. So this will be 1 minus 2, and the answer will be negative 1. So is negative 1 less than 0? The answer is yes. So meaning in this range, or rather in this interval, so in this interval, the function is decreasing because the function in this interval is less than 0. And then so this interval is for the decreasing part. Let's try to check this interval in between. So we can also get 90 degrees because we know that 90 is between 60 and 300. So cos 90, the answer is 0. So if you put 90 there, we find cos 90, the answer is 0. 0 times 2, the answer is 0. So 1 minus 0, the answer is 1. So at this point, the answer that we're finding is positive. So is a positive number less than 0? The answer is no. So meaning in this interval, the function is not decreasing, but it's increasing. And then let us also try to get any value this side. We can get 360, because I know to say 360 is greater than 300. So we know to say cos 360, the answer is 1 rather. So the answer is 1 for cos 360. So if we replace 1 where there is cos x, because when you put 360 here, you're getting cos 360, which is 1. So if we put 1 there, we'll have something like this. So we'll have 2 times 1, which is 2. then we have 1 minus 2, which will give you negative 1. So is negative 1 less than 0? If the answer is yes, so negative, we're getting a negative answer here. Even this side we got a negative. So since the answer this side is negative, meaning it's less than 0, meaning dy dx in this region is less than 0. As a result, we conclude that in this region the function is decreasing. So the function is decreasing this side. So this is how you determine decreasing and increasing functions. So the increasing region, or the interval where the function is increasing, is simply just from 60 to 300. If you want, you can write it like this, or you can write it as 60 degrees less x less 300 degrees. So this is the interval in which the function is increasing. Then the two intervals where the function is decreasing are this and this one here. Alright, so this is how you determine. So thank you very much for watching today's tutorial. I guess question 29 is also straightforward, because for this one you not determine for the increasing, for the decreasing part, but you only focus on the increasing part. What I mean is that after doing everything that I've done in the previous question, you, instead of considering dy dx to be less than 0, since they are asking us to determine for the increasing part, means that we're going to consider the other part, which is dy dx greater than 0. So we forget about this part, because this one is used to find for decreasing functions, but this one is the one that defines increasing functions. So in this case, we're just going to use greater than 0. Alright, so thank you very much for watching today's tutorial. See you in the next tutorial. If you want to join the group where I'm posting these tutorial videos, inbox me on WhatsApp, and then I'm going to show you. So that my WhatsApp lines are just on the screen here, and don't forget to subscribe to the channel and also click the notification button. My name is Harmtedy. Shalom, shalom.